Let's now start working on the Bankist website. And we're going to start by implementing smooth scrolling. And the functionality that we're going to implement now is when we click on this button, then it will smoothly scroll to this first section. Okay, so that's it. Simple effect. All that happens is one click, and the effect is that it smoothly scrolls here to this first section. So we're going to see two ways of doing this. First, one a bit more old school, which will allow me to show you a couple of interesting stuff. And then finally, I will show you the more modern way, which only works in super modern browsers. So let's start by selecting the button and the section that we want to scroll to. So that button is, it's this one, button scroll to, all right. And then the section is this one, section 1. So with this ID of section 1. So const button scroll to is document.query selector. All right. And now section 1 is document.query selector. And now it's the ID, so that's the hash, and then section --1. So that's the easy part. And now, as always, we need to start by adding an event listener to the button. .add event listener on click, and then our function. And let's actually give it the event. So in the first way that we're going to do, we need to first get the coordinates of the element that we want to scroll to. So let me show you how. So S1 coords, and that's section 1 dot get bounding client rect. All right, that sounds like a mouthful. It's actually pretty straightforward. Let me show it to you actually first. So when I click this, then we get this DOM rectangle. All right, and it has all of these properties. So the X position, which is measured from the left side, the Y position, which is measured from the top, and then the width of the element, the height, and then a lot of other properties. All right, and this element is probably not the best one to understand this. So let's get this rectangle for the button. So that's the element we just clicked. So e.target, remember, so e.target is essentially this element here. So the one that was clicked. And now get bounding client rectangle as well. And so let's take a look at that second one. So this 30 pixels here is the distance between the border here of the browser. All right. And then this Y is this distance from the top. Then we also have the width, which is this 112, the height. And yeah, here we also get the top, which is in this case similar to Y. Okay. But it isn't always, because when we scroll, then X and Y actually change. Let me show that to you. And if I click this again now, then let's take a look here. So you see that Y is now only 168 pixels. And so that's the distance between this element and the top of this viewport. So this bounding client rect is basically relative to this visible viewport. All right. And in fact, we can also get the current scroll position. So since we're talking about scrolling, let me show that to you as well. So current scroll, so that's the X and the Y positions, just so we see what we are looking at. So these values are at window, page X offset, and page Y offset. So let me just scroll somewhere here, click this, And so we get that the current scroll is at 0 from X, so there's no horizontal scroll, and vertically we already scrolled 290 pixels here at this point. So when we're at the very top, then these two values should both be 0. And so yeah, now they are. So basically this y coordinate here is the distance between the current position here of the viewport and the top of the page. So here at this line, for example, when we're here, if we get to scroll now, well, now we can't because we can't click on the button. But yeah, you get the point. So the distance, for example, here is now 421. So that means that from this very edge of the browser right now, all the way to the top of the page, it is 421 pixels. Okay? And sometimes that's very important to know in certain applications. And if you're even more curious, then since we're talking about coordinates and stuff, we can also read the height and the width of this viewport. So again, of this rectangle in which we can see the current portion of the page. So height and width of viewport, and they are at document.documentElement.client height, and then the same with client width. Client width. All right. So you see that this height here is 588 and the width 1067. So if I change this here, so this is kind of half now. So let's see what value we get now. And so now it is 276. Okay, and so that's because I decreased that visible box there. And so the height of the viewport is of course different. So let's reload here, click again. And so, yeah, here we get all kinds of interesting information about coordinates, scrolling, and dimensions of the viewport. All right. But anyway, the goal of actually getting these coordinates is because we need them to scroll to this first section here. All right. So basically, we need these coordinates here to tell JavaScript where it should scroll to. So let's now do that, actually. So scrolling, and we use window.scroll to. Okay, so that's a global function that's available on the window object. And here the first argument is the left position. And so that is at S1 chords. And let's take a look here. So this is the one. Oh, now it's gone. So we are interested here in this left value right now. So it is 0, and that's good because we don't want any horizontal scroll. Then for the second one, we're going to be interested in the top, which is, again, the position from the top of the viewport. So the section starts here, so it's basically these 270 pixels right there. Okay. So left and S1 chords dot top. So let's give it some more space and let's try it. And indeed, now it worked. So we are now here at the top of section 1. Okay. And so that's because the top was at 730 pixels. And so that's the distance that was scrolled. However, watch what happens when I click again. So now it doesn't really work, does it? Well, that's because this top here that we specified is always relative to the viewport, but not to the document. So not to the top of the page, basically. Right? So let me show it to you again. So it works when we are here. All right? And that's because this Y position here, which is the same as this top, is 429. which is basically the distance between this point and this point. Okay? But if we're doing it here, then the distance between the line and the top of the viewport here is a lot less. So it's only like 200 or something. So let's see. It is only, actually it's only 112. Well, that doesn't make sense. Well, actually it's this one. So it's only 333. All right. And so basically it only scrolled to position 333, while in fact we wanted to scroll all the way to here, which was at something like, so it was at 492, or actually at 713. Okay, so I know it's all a little bit confusing, and in order to really understand all of these numbers, you have to play around with this a lot by yourself. Otherwise, it's going to be hard to make sense of this. But the solution to this problem is to simply add the current scroll position to the top value here. And with this, we will then determine the position of this section here, not relative to the viewport, so to the top of this browser window here, but instead to the top of the page. Okay? So again, the position of this section here is always this top, which is from here to the viewport, plus the current scroll position. And so that's the distance from here all the way to the top. Okay, so let's add that here. And again, to really make sense of all I'm saying here, please play around with this a lot by yourself. Okay, so page Y offset. And here it should actually also be window. And then we also, just for the sake of completeness, add it here as well. So window.page X offset. Okay, so let's see if it still works here. And it does. And now let's try it from somewhere else, like here. And now it works. Now it goes to the correct place. And so by doing this here, we basically determined the absolute position of this element relative to the document, so to the entire page. And that's important to note. So if you need that, then this is how you calculate it. So again, the current position plus the current scroll. All right. Now we can even make this better. So dot scroll to again, because there is a way of making this animation nice and smooth. And this works by passing in an object now instead of just one argument. So let's get these two, and then let's comment all of this out. And so the properties that we need to specify are the left. So this is the left. This is the top. And so this is actually called top. And then we also have a property called behavior. And so here we can now specify smooth. All right. So to implement smooth scrolling like this, we need to specify an object with the left, top, and behavior properties. So let's try it out. And it works. Great. So that is a lot better, isn't it? And again, it also is going to work from this position. And the browser automatically figures out the speed it should go to make this look really nice. All right. So this is kind of the old school way still of doing it. So manually calculating all of these values here and then saying that we want to scroll to this position. All right. But there is a more modern way, and it works like this. We simply take the element that we want to scroll to, and that is section 1. And on that, we call scroll into view. And then we pass in an object and specify, again, behavior, and set it to smooth. And that's actually it. Then we don't need any of this. Okay, let me prove it to you. And it works just the same. So without any of these weird calculations here with these weird positions and all of that, it's all unnecessary if we are able to use this function here. And again, this only works in modern browsers, but if you only need to support these, then you are 100% fine using only this method. But I think it was still a good idea to show you all of these different numbers here. So like calculating the current scroll positions or the current window positions and sizes, and also all the sizes of the elements that we can get using this function. And by the way, these client height and width here are not counting with the scroll bars. It's just the dimensions of the viewport that are actually available for the content. And of course, that excludes any scroll bars. In this lecture and the next ones, we're going to talk a little bit more about events. Now, we already worked with events before, of course, but now let's add some more important concepts and also make things a bit more clear. So, an event is basically a signal that is generated by a certain DOM node. And a signal means that something has happened. For example, a click somewhere, or the mouse moving, or the user triggering the full screen mode, and really anything of importance that happens on our web page generates an event. And as we already know, we can then listen for these events in our code using event listeners, so that we can then handle them if we'd like. But no matter if we handle a certain event or not, for example a click, that event will always happen when a user clicks. So it doesn't matter if we're actually listening for it or not. All right? And that's going to be important to understand also in the next video. Now, we already worked with a couple of different events earlier in the course, but now let's take a look at another type of event, which is the mouse enter event. But let's start by selecting an element, and let's use the h1 element this time. So we have an h1, which is this here, and so let's just say document.querySelector h1. And now we can listen for that event. So we already know about this one, so add event listener. But in this video, we're going to take a look at two more ways of listening for events. All right. But anyway, let's now use mouse enter, as I said previously. So mouse enter, and then as always, a function with an event. So the mouse enter event here is a little bit like the hover event in CSS. So it fires whenever a mouse enters a certain element. So just as the name says. So whenever that happens, let's create an alert which says add event listener, just so we know where this one is coming from. Great. You are reading the heading. Okay. And let's try it out now. And indeed, as we hovered over it, we got this alert. And if we do it again, it comes again. So that works just fine. Let's now actually take a look at a list of different events on MDN. Let's say JavaScript events. And yeah, this is what I was looking for. So this event reference. So let's take a look at some of the more important ones. So we see that we already used the click events. So where are they? So here, mouse events. So click, this is the one we have been using all the time. But this time we used mouse enter. And as you see, there's then also mouse leave, which is fired off when the mouse is moved off the element. And then you have all of these. And of course, you can take a look at this list here by yourself. And you see that there is all these different kinds of events that we can eventually learn how to respond to. But usually the most important ones are the ones related to mouse and the keyboard ones. Okay, but for example, there are also some for the clipboard and for full screen and for resizing the page and for when we scroll the page and so on and so forth. Okay, so here is the warning again. But anyway, let me now show you another way of attaching an event listener to an element. And that is by using the so-called onEvent property directly on the element. So for example, when we want to listen for mouse enter, there is a property called onMouseEnter. And then we can simply set that property to this function. All right. So here, let's do that. Just to see. And so now we get, of course, the alert from before, but we should get a second alert as well. And indeed, here it is. Okay. And so actually for each of the events that we just saw in the table, there is one onEvent property like this one. For example, also onClick. All right. However, this way of listening to events is a bit old school. So it used to be done like this in the old days, but now we usually always use addEventListener. Okay, so I'm just showing you this in case you ever come across this way of listening for events. Now there are two ways why addEventListener is better, and the first one is that it allows us to add multiple event listeners to the same event. So we could do this here again and simply change the function here. But if we did the same with this property, then the second function would basically simply override the first one. All right, so that's one advantage of addEventListener. And the second one, even more important, is that we can actually remove an event handler in case we don't need it anymore. And this is something that we hadn't done before, but it's actually very simple and very useful from time to time. And to do that, first we need to export the function into a named function. So we cannot just write, for example, the same function and expect it to work. That's not going to work. So let's take this here out. And let's say alert h1 is this function. And then on h1, here I want to pass in that. Let's just comment out this one so it doesn't get in our way. And so let's see. And indeed, it still works. That was not on purpose, but we can now actually prevent that from happening. So after we listened for an event and then handled that event here in this function, we can then remove that event listener. So here we can say h1 and now remove event listener. And again, we have to say mouse enter and then the name of the function. And so this is why we had to export the function into its own function. All right. And so let's see. So indeed, we got this alert now. But if I now hover this again, then nothing happens. And that's because in the same event handler function, we also then removed the event listener. And so this makes it that we can only listen for the event once. So this is a nice pattern whenever you only want to listen to any event just once. But of course, this doesn't have to be in here. So you can remove the event listener at any place in our code. For example, we could remove it after a certain time has passed. So let's use setTimeout here and a simple arrow function. And let's say that after 3 seconds have passed, we want to remove the event listener. So now we get it. And right now, apparently 3 seconds have already passed. And so now it's gone. All right. So this is another pattern of removing the event listener. But of course, there are going to be other situations where this is helpful. Finally, there's also a third way of handling events, which is by using an HTML attribute. Now this one should actually not be used, but just for the sake of curiosity, I'm going to show it to you here. So let's actually this time use the onClick, just so we have a different one. But so this is quite similar to what we did here before in the JavaScript with the on mouse enter. We're simply defining it directly in HTML. Then here we basically specify a string, and then we say what we want to happen. So this is pretty weird, but well, this is kind of old school JavaScript from the early days. Alert. Okay, and so now when we click here, then we get HTML alert. All right, but anyway, we don't need to bother with this one, but I'm just going to leave it here for you as a reference. And so that's different ways of handling events and also how to remove event listeners in case we don't need them anymore. Next up, you will learn about the most important property of events, which is bubbling. So let's move on right to the next video. JavaScript events have a very important property. They have a so-called capturing phase and a bubbling phase. So what does that mean? Well, let's find out. So here we have a very simple HTML document along with a DOM tree, but only for the anchor element that's represented in red here. So here we can see exactly all the parent elements of that red anchor element. And that's because we're going to simulate what exactly happens with an event when someone clicks on that link. So maybe pause the video for a minute and analyze this structure here. But anyway, let's now say that a click happens on the link. And as we already know, the DOM then generates a click event right away. However, this event is actually not generated at the target element, so at the element where the event happened, in this case the click on the anchor element. Instead, the event is actually generated at the root of the document, so at the very top of the DOM tree. And from there, the so-called capturing phase happens, where the event then travels all the way down from the document root to the target element. And as the event travels down the tree, it will pass through every single parent element of the target element. So in our example here, the HTML element, the body element, the section, then the paragraph, until it finally reaches its target. As soon as the event reaches the target phase begins, where events can be handled right at the target. And as we already know, we do that with event listeners such as this one. So event listeners wait for a certain event to happen on a certain element, and as soon as the event occurs, it runs the attached callback function. In this example, it will simply create this alert window. All right, and again, this happens in the target phase. All right, now after reaching the target, the event then actually travels all the way up to the document root again, in the so-called bubbling phase. So we say that events bubble up from the target to the document root. And just like in the capturing phase, the event passes through all its parent elements. And really just the parents, so not through any sibling elements. So as an event travels down and up the tree, they pass through all the parent elements, but not through any sibling element. But now you might be wondering, why is this so important? Why are we learning about all this detail? Well, it is indeed very important because basically it's as if the event also happened in each of the parent elements. So again, as the event bubbles through a parent element, it's as if the event had happened right in that very element. What this means is that if we attach the same event listener also, for example, to the section element, then we would get the exact same alert window for the section element as well. So we would have handled the exact same event twice, once at its target and once at one of its parent elements. And this behavior will allow us to implement really powerful patterns, as we will see throughout the rest of this section. So this really is very, very important to understand. Now, by default, events can only be handled in the target and in the bubbling phase. However, we can set up event listeners in a way that they listen to events in the capturing phase instead. Also, actually, not all types of events do have a capturing and bubbling phase. Some of them are created right on the target element, and so we can only handle them there. But really, most of the events do capture and bubble, such as I described it here in this lecture. We can also say that events propagate, which is really what capturing and bubbling is. It's events propagating from one place to another. All right, so I hope that all of this made sense, and so let's now actually see this in action in the next video. So let's now see event propagation in practice, and mainly event bubbling. And we're going to do that by attaching event handlers to this navigation link here, and also all of its parent elements. Then, as we click this link, we will give all these elements random background colors, and this will then allow us to visualize exactly how event bubbling is happening. And it will make sense once you see it actually working. And let's actually start by creating that random color that I just mentioned. And the random color is basically just a string like RGB, and then with a value between 0 and 255. So here with commas, actually. And so you see that VS Code is already showing this as a color. So let's start with the random number generator. And this one I will simply write now because we already did it in the previous section. So that's going to be math.floor. So maybe I could have just copied this code here, but then it would appear that this code simply magically appears, and I don't really like that when I'm watching a tutorial myself. Okay, so this was the formula that we used before to generate a random integer, and now we can use that to create a random color. So random color, and let's use another arrow function here. And so now we simply need to follow this formula here. So here we need random int, and as I said, with a value between 0 and 255. So this, and then 3 times. Okay, and that's it. Let's just check it out. 255. Oh, that's not what I wanted. And so you see that random colors keep appearing down there now. Okay, but now let's actually attach the event handlers that I was mentioning. So I want to attach an event handler to this link and then to the parent elements as well. So let's check our HTML. And so the link itself is the nav link. And then let's attach an event handler also to nav links. So that's going to be this entire header there. Let me actually show it to you here. So I'm going to use this link here. So you see it's appearing in blue up there. So this link, then this whole element, and then also this entire header here. So that's with the class of nav. So document.query selector. And here we are actually going to need the event. And then, as always, just to see if it works, and it does. So let's now grab some of these others. So there's links and nav. Remember, so that's the three that we want to use here. And so anyone that we click now, we will see link. So for now, that doesn't really matter, because what I want to show you now is what happens when we assign a random background color to first starting with this one. So we can say this, and remember that in an event handler, the this keyword points always to the element on which that event handler is attached. So in this case, that's going to be this link. All right. So we say this dot style dot background color and set it equal to a random color. And for now, let's just get rid of these here, just to see if this works. Oh, and now we see this is jumping around, and that's because of this hash there. So let me get rid of this for now. And this here as well. And now as we click, it reloads the page. So what we need here is this, I guess. And so yeah, now it works. And so as we click here, we see that the color of this element keeps changing. But now, what if we perform the exact same action on the parent element? So let's copy this and put it here. And again, keep in mind that this nav links element is the parent of this link. So it's all of this block here. So when I click this link now here, what do you think is going to happen to the nav links element? So to that whole container? Well, let's see. And you see that the container also got its own random background color. So based on what we learned in the last video, why do you think this is happening? Well, just as we learned before, the event actually happens at the document root, and from there it then travels down to the target element. And so in this case, that is this link. And then from there it bubbles up. And bubbling up means that basically it's as if the event had also happened in all of the parent elements. And so that is the reason why this exact event is now also being handled by this event listener here that is on nav links. Okay? So again, it is as if the click event here on this link had also happened right here in this element. So in the nav links element. All right? So both of these handlers here are now handling the same event which happened here on this link. And as we keep clicking, of course, the same keeps happening. Now, what do you think happens when we click only outside here? So only in the nav links? Well, let's see. So you see that the color on the link itself keeps unchanged. And that's because this is the parent element. And so from here, the event only bubbles up to its parent elements. So let's see what happens when we actually also paste this here into this whole nav bar. So let's see. And indeed, now the click event that happened here was indeed handled in all three places. So in all three elements which have a click event handler. Great. But let's now dig a little bit deeper and talk about the event target. So here let me log to the console. First saying that this is the link, and then event.target. And the target is essentially where the event originated. So where the event first happened. So this is not the element on which the handler is actually attached. Okay? So again, this is where the event happened. So in this case, where the click happened. And it is not the element on which the event handler was attached. So let me put the same here also. And let's call this one here the container and the nav. Okay. And now watch what happens again when I click on this link. Okay. So one more time, all the three elements got a random background color. And you see that the target, which is this one here, is always the same. Okay. So in all three handlers, the target element will always be the same. And that's, of course, the element where the click first happened. And it appears in all the three handlers because all of them are essentially handling the exact same event. So this E here, so this event that each of them receives, is indeed the exact same event. And again, that is because of event bubbling. So the event originates here in this link, but then it bubbles up to its parent element, which is this one, and from there to its next parent element. And from there, it will travel even further up in the DOM tree. And so we can then handle that event in all of the parent elements. And that is exactly what we did here. All right. Now, besides the target, there's actually also the current target. So let me log that here as well. And the current target is indeed the element on which the event handler is attached. So e.currentTarget, and here e.currentTarget. So if we do this now, then you will see that the current target is not the same. Well, in the link it is, of course, because that's where the event happened, and it's also where the handler is attached to. But then here, it is, of course, the nav links, so the container, and here the whole navigation element. All right, and so you might have noticed that the current target is exactly the same as the this keyword, right? So the this keyword is also the one pointing to the element on which the event listener is attached to, so such as we used here. And all of this is important to know when you really want to gain a deep understanding of the DOM and how it works. So here you see we got indeed true. So the this keyword and event.currentTarget are going to be exactly the same in any event handler. Another thing that I wanted to show you is that we can actually stop the event propagation. So let me show that to you. Propagation. And so all we have to do is to simply call on the event stop propagation. And that's it. So when we try to do the same thing now, watch what happens. So now the two parent elements did not change their background colors, which means that the event never arrived at those elements, right? That's why they weren't handled there. And again, that is because we stopped the propagation right here, okay? And so the propagation phase then never happened for this event. And therefore, these events never reached this element and also not this element. All right? Now, in practice, that's usually not a good idea to stop propagation, but I still showed it to you here in case you really need it sometime. So stopping the event propagation like this can sometimes fix problems in very complex applications with many handlers for the same events. But in general, it's not really a good idea to stop the propagation of events. So as we just saw, these three event handlers that we set up here receive events from the target elements and also from the bubbling phase, right? So in other words, the event handler functions are listening for click events that happen on the element itself, like this, right? Or like this, and where now, of course, only the background color of this one changes. And they're also listening for events that keep bubbling up from their child elements. And that's the reason why the color changes in all of the parent elements here as well. So the two phases that I just described are phase 2 and phase 3 in the slide that we saw in the last video, right? But now, what about the capture phase? So that was phase 1. Well, as we learned, events are captured when they come down from the document root all the way to the target. But our event handlers are not picking up these events during the capture phase. Remember that? So I mentioned that add event listener here is only listening for events in the bubbling phase, but not in the capturing phase. So that is the default behavior of the add event listener method. And the reason for that is that the capturing phase is usually irrelevant for us. It's just not that useful. Now, on the other hand, the bubbling phase can be very useful for something called event delegation. So that's something that we're going to do in the next lecture. However, if we really do want to catch events during the capturing phase, we can define a third parameter in the add event listener function. So, for example, here, we can set the third parameter to true or false. And so let's set it to true. And so in this case, where this useCapture parameter is set to true, the event handler will no longer listen to bubbling events, but instead to capturing events. Now in practice, that's going to look the same here. Okay, but as we take a look here in our log, you will see that now the nav is actually the first appearing. And let's clear that here and see it again. So you see that now the first element through which the event passes is the navigation. And the reason for that is that this element is now actually listening for the event as it travels down from the DOM, while these other ones are listening for the event as it travels back up. And so that happens later, and therefore the nav is now the first one to show up, because this, of course, is the first one to happen. Because first the event travels down all the way to the target, and only then it bubbles back up. And so these other two event handlers here, they are looking for bubbling events, and so therefore they are going to happen after this first one. Now they're still all working with the same event, they're simply doing it in different phases of the event propagation. And if that sounds confusing, then please take another look at the slide that I showed you in the last video. You can imagine that slide maybe with these elements that we're working with here, and then picture the event traveling down and up again, and how we capture it here in the capturing phase. So with this flag here set to true. So I hope that made sense, but let's now actually get rid of this. So by default, this is set to false, and so getting rid of this is the same as setting this argument to false. So as I said, capturing is actually rarely used these days. And the only reason why both capturing and bubbling actually exist is only for historical reasons. So from the time where different browsers implemented different versions of JavaScript. But anyway, what really matters that you really understand here is that why these three boxes here get three different background colors, even though the click only happened on this element. And I think I made that really clear in this video and also in the last one.